Hello, my name is Juan Cañón, mechanical engineering student. From the fluids mechanic course, I have come to explain about pumps in simpler pipes. My teacher is Hector Augusto Dusan Moreno. What does it consist of? Equation such as Darcy Waite or Collier White, the design of simple pipets indeterminate wide one or more rotor dynamic pumps study the effect above online of gradient or piezometric line and the total engineering line of flow in pipes. Pumps in piping system. Rotodynamic pumps are classified into centrifugal pumps, radial flow. Water enters the pump axially but is driven in the directional radial. Axial flow pumps. Water enters and leaves the pump in the axial direction. They are usually low head and high head pumps capacity. Mixed flow pumps, the water enters the pump in the axial direction and the exiting wide velocity components both in axial direction and radial direction. These pumps can be expressed using dimensional parameters called specific speed and c. Q, flow rate in use gallon per minute GPM, H, total head of the pump in feet, and rotational speed in revolution per minute RPM. Hydraulic gradient line in pump pipe system. Pumps are hydraulic mechanic whose purpose is to convert rotational mechanic energy into energy kinetics or potential of the fluid within the system. The effect of this conversion is to add energy per unit for weight, velocity, head, or pressure head at flow. Increase that is detected by the pressures goes upstream and downstream of the pump. Increasing the energy is reflected the gauge height and edge pump, those affecting the shape and slope of the main mentioned lines. Um, Exercise the explanation pumping load exercise of a pump. Noting the pumping flow determine the total dynamic head of the pumping must during the pump is show the two components of the head total dynamic of the pump static or geodetic head and dynamic head expressed by head loss in the conduction. Surely we will all know what the centrifugal pumps have to fundamental characteristics. The flow task given in cubic meters per second. Cubic meters per hour are also in liters per second, and the pumping head or the pumping head that it's normally given in meters. Water's column in meters. Uh, Although is also given in PSE for those why use or American system for units. It is also given in some cases in feet. I can give in transversal units, but the most used methods that exist international measurement system. We know the flow rate. Let's take an example. We have our reservoir and pump that traffic waters. In a tank, we know the water levels and the discharge hertz. The difference in level. This difference in level is what we normally call the static head or the static popping head. Suppose that there are 20 meters, and the way half the pump flow rates of 5 liters per second. And we know the diameter of pipeline, the pumping head or total dynamic height also was height. Total dynamics, which come from English, is some place they call it. It comes from English total dynamic head or total dynamic height, while the pumping H or the pumping load is equal this, that is static load plus the sum of the loaded weight, also called dynamic load. The first component, that is load static, is different in level from the water level here in the suction to level at the discharge. It is logical that the pump to overcome this geodic load is also called Heldic load or the Heldic height, which give the difference is level before this will be plus the loss that will happen by length and the accessory elbow loss per gem. Uh, let's say that the diameter of the pipette 4 inch or 100 millimeters, and I have no sub. We have to change 5 liters per second to let's determine the total load we have, and geodetics or static load we have said is to 20 meters. Then already we know this is 20 meters, then we are saying we need to calculate the losses. What data is missing here to calculate the so the length of the pipe suppose is um, 500 meters of pipe, then to calculate the age of pumping, the age of pumping total dynamic head will be equation to the 20 meters different plus the loss per length. Now we're going to determine this component by William equation, Hansen since it's above water. Finish. Um, this is bibliography. Thanks.